So as he introduced me, my name is Lima. I work at Comcast. I've been working at Comcast for about 8 years or so it's been a while. The past 2 years, my focus has been on personalization/recommendations, specifically building out this team. When I first started managing it, it was about 2 people, which was not enough to have the impact that personalization should have on a content discovery platform for millions of customers. And then, so of course, we've tripled it in size, which, 2 times 3, do the math. But it's a small team that gets a lot done, and I'll showcase that in the deck that I'll soon present. But yeah, that's me in a nutshell. Been working at Comcast pretty much since I graduated college. And yeah, and then the guts of this talk. So this is somewhat of a case study, and case studies are hard because sometimes they're not as interesting as they could be. So there's like 2 types of case studies if you think about it. There's the case study where a company talks about their journey from point A to point B. And then there are case studies where someone goes into depth about some framework or some technology or language that they use to solve some problem. I'm going to try to do a little bit of both, where I talk about our journey at Comcast, how we started at the bottom and now we're somewhere. And then, to also talk about the engineering principles or the changes that we made from an engineering perspective that got us there. So yeah. And then if we can't get it going, I can keep riffing on what I think I'm going to talk about.
What was the problem?
You're just going to... Okay, that works too. So the problem that we were solving was personalization was not used to the extent as it should have been for our content discovery platform. And I have screenshots of this, but in a nutshell, we had this, this user interface that is on our set-top box, web, mobile devices that's used to discover movies and TV shows. There was very little personalization utilized in those experience back in like 2017, 2018, even the beginning of 2019. And then as of recently, or the fruits of all of our labor from the past 2 years, now it's like highly personalized, and you'd see that in the screenshots. So the problem that we were attacking was, it wasn't the machine learning, or it wasn't the engineer, or it wasn't the research or the model or deep learning, or it wasn't anything to do with the ML itself, but rather it was the actual engineering under the hood. The engineering was not at the place it needed to be able to truly build out this machine learning platform, which is not something that we really talk about often. Usually we'll say, okay, if the algorithm is better, we'll get better results. Or, if we go the deep learning route instead of collaborative filtering, like we're just really going to increase that engagement. But really the case for us was it could have been the best algorithm. It wouldn't really have mattered because the engineering that was built around that algorithm wasn't really built to scale. And there are various reasons for that. Oh my gosh, it works now. Thanks. So how do I click? This button thing? Okay, the green button. Cool. Thank you. Okay, thank you for that. So I kind of already did the introduction at some level of some sort, and I kind of already said that this is a case study. And I want to say that there are 2 different types of case studies, which I've already went into. There's the one where you talk about our journey, and then you talk about a specific technology and framework. What I have here is, this is at a really high level, an architecture that we built out. And what I want to make the point is, I'm not really going to go into detail in why we selected Redis for our caching layer, or why we selected Flink for one of our data processing jobs and Spark for another one. That's great information that we can talk about later. But rather, go into a bit of detail holistically of the changes that we made so that we could, get from point A to point B. Specifically, in this example right here is we needed some data, and we need to quickly access that data in runtime. Whether that data is specific to your subscription, meaning you have HBO, Stars, Showtime, and then with that information we'll personalize some row for you, or whether that data is specific to your recently watched TV shows. We needed to aggregate that data, stick it into some caching layer, and then have a runtime service access that quickly. That's kind of what I'm going to talk about in this talk, is these holistic approaches to the problems we were trying to solve. Something that I'm not going to go into are the various phases of machine learning. So there's a lot of steps that are needed to orchestrate machine learning at a very large scale. And I think the reason why I like this conference is because that's what this conference is about. It's about all of the engineering that's needed to do this. It's all of the engineering, all of the tools, the frameworks, the processes that are needed to essentially support the little black box that is typically the machine learning code. So I'm not going to go into detail on the like offline evaluation, online evaluation, how A/B testing is important. Well, I'll touch upon A/B testing. I'm not going to go into like, after you do your online evaluation, then you'll incrementally roll it out, all these good details that we're all used to at this point. But I will go into, you need visibility for all of this, or you need a really good data platform to support all of this and why you need that. All right, so this is the screenshot I alluded to earlier. This is the X1 platform. It is our user interface for discovering content on our Comcast video products. If I were to give this talk circa like 2017 or 2018, I wouldn't be presenting this because we didn't have this experience. This essentially is the end result of all the hard work that me and my team have done the past 2 years, is this highly personalized For You section in On Demand. It uses different flavors of personalization and recommendations to get the customer to the content we know they'll hopefully like, and then recommend new content. So at a high level, whenever I say anything about personalization, content discovery, recommendations, think of this screen and think of what we're doing to make this screen better. All right, so started from the bottom. If we really want to talk about starting from the bottom, we'll need to get into a time machine, and this is a DeLorean. I haven't actually watched the movie, but I've seen this slide in so many tech talks, so I just felt like I had to be that stereotypical person that has this in their slide deck too. So I'm going to go back in time in this car and then ask myself the question, how often was the recommendations platform utilized circa 2018? Meaning, like, how much was our services invoked? How much were we actually like leveraging personalization to improve our content discovery experience? Well, the answer to that is pretty simple. It was 0. It was nada in a different language, in Spanish. It was null in German. I'm using different languages to really show the effect that personalization was not used to the extent it should have been for our Comcast video products. So luckily, that's not the case today. So fast forward to today, get back in that car, and then come back to the future, or come back to current time. And we have this great For You experience that I've already alluded to earlier. It's highly personalized. We used A/B testing to prove out that this is something that we should launch. And then with that A/B test, we saw that there was an increase in consumption for both movies and TV shows for the test segment compared to the control. So that's great. This is where we are today. We're not at the bottom anymore. This is awesome. And this is another success, or another win, is a highly personalized TV section. So we always had a TV section in On Demand for our Comcast video products, but now it's more personalized and very similar to the For You section that we recently launched. We also A/B tested that, and we also saw that there was an increase in consumption and engagement as a result of introducing personalization. So this is what we expect. We expect personalization to do better, right? Well, how did we get there, and what do we do to get there today? And that's kind of what the meat of this talk is about. So if I'm going to talk about how we got there, I'm going to talk about our deficiencies at the time, because it's way more fun to talk about how we failed or where we sucked, and then what we did to not suck as much. And to do that, we had to really focus on where were we failing. And it really wasn't because of the machine learning or the research or the data science, and I've kind of alluded to that earlier. It was the engineering. It was the engineering that was supposed to support this complex problem. So I always reference this when I talk about this topic every time, and I'm pretty sure everyone else does too. It's this paper written by Google developers at the time that was submitted to the NIPS conference. Essentially, it's called Hidden Technical Debt in Machine Learning Systems. If you haven't read it, check it out. The gist is that there's a lot of engineering that's needed to facilitate machine learning at any scale, and if you don't give the attention or the detail that's needed to build out the engineering to support that machine learning, you're going to acquire this technical debt, and then it's just you're going to end up essentially doing whack-a-mole and putting out leaks where you don't want to. So in a nutshell, there's a lot of data verification, data collection, feature extraction, serving infrastructure, monitoring of all of these components so you have some visibility into what's going on, and of course configuration, resource management, all these key words that you've heard before for any engineering platform, but especially applicable to machine learning systems. And specifically in this paper, they outline only a tiny fraction of the code in many machine learning systems is actually devoted to learning or prediction. The rest is what they refer to as glue code, what I'll refer to as engineering. All right, so let's go back to our deficiencies. Where did we suck, and what do we do to suck less? Number one, we lacked a reliable source for data. And this is super important. And I think often when we're thinking, or when a product owner, a business owner, whoever is thinking about like, oh, we need to innovate and we need to use machine learning or we need to do something with AI, they kind of forget, first we need to make sure we have the proper data set to be able to enable those innovations. So it's kind of where we ran into. So this was our data platform like 3 years ago before I joined this team. There was an external HDFS cluster. It was an on-premise. I think it was like Cloudera was the Hadoop distribution, and it was part of Comcast. It was another team hosted it, and somehow data would get in there, and then we would disk copy that data every day or so. It doesn't sound too bad. It doesn't sound terrible, but it doesn't sound great. Some of the problems with that was that copies would fail, whether for network issues because you're copying large chunks of data, or because there was no data for that day. The schema would change underneath us, and that's kind of one of the worst feelings is when you don't write defensive code and you end up reading data that, reading events that have changed, and then you're like, well, what the heck is the problem? And then, in that same context, visibility in the origins of the data set were unknown. What's that magic cloud bubble? We weren't really sure how data was getting into that external HDFS cluster. And again, when I say external, I mean within Comcast, just external to our team. So when we had to debug quality issues with our recommendations platform, specifically if like QA or someone on the product side would be like, I should be getting this recommendation. I watched this movie like 10 times for some reason. We wouldn't be able to be like, well, we didn't get that event, so we have no idea what's happening. So that's what I mean by visibility. And then just general operational ownership. That's a key construct I have in this presentation is it's very important to own your platform from an operational perspective, just like you should any other engineering platform. All right, so that's the past. This is kind of the future, some of the future. So we went from disk copying to lambdas. I don't have lambdas outlined in here because I kind of want to forget that we did that. Essentially, we were really excited to go to AWS. And so when we went to AWS, we were like, OK, let's try out lambdas. The problem with lambdas was we weren't keeping up with the stream of data that was coming in, and we weren't noticing that we weren't keeping up with the stream of data that's coming in until we had to do metrics for a specific A/B test, and we were like, this data doesn't seem right. Lambdas felt like a good solution at the time because we were a small team and it's a lot of configuration code, but long term it just didn't make sense. So that's why we migrated to Flink. So we have what we call a battalion of Flink agents or a fleet of Flink jobs, and what they do is they constantly consume data from some source, whether that's Kafka, Kinesis, or some queue. And then we aggregate it to S3. It's pretty simple. It was a fairly simple change that allowed us to take ownership of the data platform so that we could have a more reliable pipeline for our machine learning system. All right, so the second deficiency that we had was over-engineering. So you wouldn't think with a small team that you would over-engineer features, but it's very possible. Why that happens, I'm not really sure. Sometimes I think it's we don't understand the problem we're trying to solve, and that's a bigger, deeper question that we should ask ourselves. So I'll give an example of over-engineering. So there's this row, it's because you watched blank. So this example is because you watched Hard Knocks. It's a TV show on HBO, so I'd recently watched this TV show on HBO, and then I got a because you watched Hard Knocks row that has similar TV shows to what I just watched. And that Hard Knocks, we refer to that as the seed ID. And then the similar assets are within that row. It's a pretty basic concept. It's a recommendation. This makes sense, right? Well, we engineered the heck out of this. So there are about 5 or 6 steps that were needed to essentially get us to that point. This is circa 2018 or 2017. So let's start at the beginning. We had this S3 bucket that had data of some sort that allowed us to know if you'd watched that asset or not. And then we had a MapReduce job. And this is a while ago. This is before I joined this team. We had a MapReduce job that had some logic that said, OK, based on everything you've watched the past year, I'm going to start deriving a weighted seed. And what I mean by weighted seed, it wasn't just based on that you watched it, but it was you watched it n number of times, and compared to the other TV shows that you watched, then you said, okay, well then this is definitely a top because you watched program. I'm going to go with that. And that makes sense. If we have some researchers in here, you're like, okay, weighting makes sense. This slight complexity really isn't that complex. Let's go with it. And then we wrote that file out to HDFS. At the time, everything was plain text and comma delimited. It was real ghetto. Then we had feed loader. another MapReduce job that picked that up from HDFS and wrote it to Couchbase, and then we had our runtime services pick that up whenever the client would make a request for it, and return this because you watched row. So this is not ideal. This was not good. There's too many points of failure for such a simple feature. Okay, 5 minutes left. Good to know. So with that, we implemented something super simple, and that's this 2 steps right here. There's a external API that's available within Comcast that just gives you back what you've recently watched. Just make a request to them, use that as a seed ID, and you're done. And we also, of course, A/B tested it, because you could ask the question, well, is a weighted because you watched better than a recent because you watched? And we found with this A/B test that there was more engagement with the recent because you watched, because you recently just saw that movie or TV show, so you want to get recent movies or TVs to that. Whereas if a weighted because you watched, like let's say I watched Wonder Woman 5 times last year, I don't really care about it because it was last year. I kind of want to get recommendations on what I just watched. So this is an example of over-engineering and then simplifying it to solve a problem. Yeah. Oops, I went back. Okay, visibility, it's very important. It's something that we should care about in all engineering platforms, but especially in complex ones that support machine learning. There's a great quote by an engineer that's amazing on my team, and he says, if an alert goes to an alarm state in a forest and there's no one there, does it make a sound? That's pretty much what happens a lot with us. When we have these alarms, we'd have these triggers, and if no one really noticed it happen, then it really didn't matter. These at a high level are the questions you should ask, and I'm going to speed right through it since there's only 5 minutes or so left. But in a nutshell, it's, are you able to understand what's really going on with your platform? Not only the offline stuff, not only the data pipeline, but also the serving infrastructure, the runtime infrastructure. How is disk utilization on those services? How do those VMs look? All these important details that you typically think of when you think of engineering, but for sometimes aren't thought of when we think of machine learning platforms. And these are some pretty Grafana dashboards. Decoupling dependencies. So this one's my favorite topic, and this is architecture flaws. So one of the changes that we made back in early 2017 or 2018 was removed this architecture from our, well, it's still somewhat used, but removed it as our main way of getting personalization into our content discovery experience. The flaws with this is the jar was known as the recommendation/personalization jar. If it's embedded in an external service that's a peer team of ours, you're going to get tied to their release cycles. You're going to kind of be held against them. If you want to essentially increase your memory footprint for some reason, you want to cache something, you're going to have to ask them, well, can I do that? And they could say no, and then you can't do that. Or they could say yes, and then they could allocate more RAM to those VMs, and then you're like, well, I have to wait for all that to happen versus having your own web service or your own abstraction layer where you can manage that on your own side. And of course, there's visibility. Do you really know what's going on with that web service once that jar is embedded? And then there's the operational ownership of having something embedded in an external service. What happens if there are failures, if there are production outages? You have to also be on call sometimes. Okay, so quick note on architectures. So there's also always trade-offs when we're talking about architectures. For this one, the trade-off was clearly we wanted to get something quickly into prod. There's already a web service that is taking billions of requests per day, so let's just put this in a prod and experiment. And that's fine. That's a fair trade-off. However, long-term, it just didn't make sense. So the solution that we went with, and in case I didn't say this earlier, was implementing our own web service that proxied requests from the client and did the necessary personalization that it had to. All right, where are we optimizing for? Another question you should ask when you're thinking about your architecture. Last but not least, can't believe I sped through that, is A/B testing. So I did say I wasn't going to focus on specific aspects of the machine learning lifecycle except for A/B testing. And I'm focusing on this one because I feel like that was somewhat of our Trojan horse or our reason for success when it comes to personalization at Comcast the past year is we A/B tested everything so that we had a reason for why this was better. I think a lot of times in the past with this team, before I was on it, they would roll out features and then they wouldn't be able to say this is better because of this change. And as a result, they had to roll back or the feature didn't really get utilized because you didn't have metrics to showcase this is better for this reason. So that's why I think A/B testing is a core tenet that we've improved on our side to improve the personalization impact on X1. Done. Thank you.